Good afternoon, everyone. Thanks for coming. My name is Justin Foster from Trend Micro, and today we're going to be talking about defending your workloads from the next zero-day vulnerability. Before I get started, I want to tell you a quick story. The last time I gave a talk like this, I was in Sydney, Australia, and I flew in and landed just in time for the storm of the decade. In fact, some people were calling it the storm of the century. Houses were flooded, roads were washed out. 220,000 Australians were without power. The night before the summit, I was in the hotel room, I was watching the news, and the Premier of New South Wales came on the TV, and he said, "Tomorrow, no unnecessary travel." So I thought, just a short 26-hour flight here, and I'm going to arrive at the summit, and nobody's going to be there. The next day, I got there, and it was record attendance, packed house. Everyone had turned out to see the power of the Amazon cloud. They were there for the power of shifting CapEx to OpEx, having those access to the resources at your fingertips, being able to go global in seconds. They were there to see the power of the clouds, and the real clouds couldn't keep them away from the Amazon cloud. I also learned that day that Australians are stubborn people and don't listen to government officials at all. So let's get started. This is a continuation of a story we at Trend Micro have been telling on how to journey to the cloud securely. And in fact, more securely than on your on-premise resources. We started with a shared responsibility model, and we discussed a model that Amazon pioneered about how they take part of the responsibility and you take part of it. And we'll talk a bit about that today, but just shortly. In 2013, we talked about compliance and rigid standards for enterprises moving to the cloud. This was still the beginning. This was still early days when people were like, no, I can't do PCI compliant workloads in the cloud. No, I can't do HIPAA. All of those barriers are gone now. We're seeing every type of workload from every type of industry moving to the Amazon cloud. Last year was my favorite, actually. Last year, we went from the big picture strategy down to the small picture tactical aspects of security. The day-to-day things like incident response, forensics, investigations, and how you can use Amazon Web Services plus security tools that are API enabled to be able to automate things like audit. And I encourage you to check out these links. We've been trying to educate our users as we go. And today's a continuation of that. But quickly, who's familiar with the shared responsibility model? Okay, I see a few hands. I'm just going to touch on it briefly. In the traditional model for security, everything was your responsibility. You had to keep people out of your data center. You had to do background checks on the people that were touching your hardware. You had to control the power and cooling and infrastructure and network and patch the virtualization systems. When you move to Amazon Web Services, you're essentially outsourcing a large part of your responsibility. They take care of the physical aspects. You don't have to worry about keeping someone out of Amazon data centers. In fact, most of us don't even know where Amazon data centers are, never mind keeping them out of it. You don't have to worry about infrastructure. You don't have to worry about world-class power and cooling. You don't have to worry about network connectivity. Does it have enough bandwidth to service your application? All of that's taken care of for you. Even at the hypervisor level, Amazon is able to take care of the virtualization security. So there was an embargoed bug in Zen Hypervisor, and Amazon was able to patch that bug with little or no impact to the workloads that were on Amazon Web Services. Tremendous amount of power and tremendous amount of savings for your security dollar. But of course, when you outsource, that's where you need to verify. And Amazon Web Services made this very easy by bringing in world-class security and analytics and being able to take the world-class auditors come in and assess against standards that are worldwide to be able to make sure that they are complying to the practices that the industry has set out. So it makes it very easy. You don't have to worry about that part of it. But it still comes back to the part that's yours. So that's your operating systems, patching and maintaining those. That's your applications, vulnerabilities in those applications. That's the data at motion and at rest. And very importantly, and one that we don't look at very often, and I want to talk a bit about today, is the service configuration. The more powerful the service is, the more there's responsibility incumbent on you to configure that service. Some of the services on Amazon are easy. S3, I have a bucket, I have things in that bucket, I have a policy that applies to that bucket. Very easy to get right. When you move over to VPCs and EC2, it's more complex. Configuring security groups, configuring IAM roles. And it's important that you educate yourselves and understand that it's your responsibility to configure this securely. For instance, I could leave the firewall wide open. I could say, allow everything on every port. It will warn you. It will warn you not once, not twice, but 3 times that that's a bad idea, don't go there. But it's still something you can do. So it's important that you educate yourselves on how to do this. So today, the structure of the talk, we're going to talk about a vulnerability. We're going to pick out one sample. We're going to talk about how we respond, how we stop that initial bleeding. And then we're going to talk about a long-term repair and how this differentiates from how you would do it in a traditional data center. What Amazon Web Services lets you do to react to the next zero-day vulnerability. So the vulnerability we're going to pick out, and we're going to use a sample here, is Shellshock. Who's familiar with Shellshock, by show of hands? Okay, so lots of hands. Shellshock kept a lot of teams up, a lot of late nights. In fact, if you could count the sleepless nights on one hand, you were probably doing a good job dealing with Shellshock. It was a very serious vulnerability in a utility known as Bash. Are you familiar with Bash? So Bash is widespread. It's in Linux, it's in Mac operating systems, it's actually in some cases in Windows. And Bash is a simple, easy idea that it takes a command, and then it runs that command for you. Simple concept. The problem is there was a parsing bug in Bash that allowed people to run malicious commands. And in fact, it was this easy. We don't usually show attack code, but it was this easy. I prepend it with this string, and then I have a pipe, and I'm literally going to run my attack code after that pipe. It was so bad that it was rated 10 out of 10 and 10 on the National Vulnerability Database. 10 for how widely used it is, and 10 for how easy it is to exploit. A very serious bug. In fact, it was so serious, it's like an attacker sitting there at your keyboard typing commands. And you might say, I've got SSH closed, I don't have to worry about that. But actually, it impacted web servers too. And here's why. If we take a look at applications, if you're familiar, this is old school technology. I remember back in the day using this, but a /CGI bin. Anybody ever seen that? CGI bin? Yeah, it was an old way to take foreign inputs and process them on your back end. And what we're going to do is we're going to use that, because CGI bin is powered by Bash, to now extract your passwords. We're just using a curl. It's a Linux-based text browser, and we pulled your passwords. Next, we're going to pull your location of your SSH keys off those machines. Then we're going to get a little worse, and we're going to use that same technique to pull the private key of your certificate. This is bad news. I mean, attackers could set up a web server in front of your web server, do a man-in-the-middle traffic, see everything that's coming in, pass it on to you, see all of your private data. They've accessed your machine. So one first tip here, a better place to put your private keys and put your certificates is actually the elastic load balancers. Don't put it on the machines at all in case they get compromised. So when was Shellshock, and therefore Bash, introduced? And it was actually way back in 1989. If you can remember that, some people in the audience I don't think are old enough to remember that year, but 1989 is when this utility came out. It was the birth of the internet. It was the very beginning. It was also the fall of the Berlin Wall. And most importantly, it's when Taylor Swift was born. This was state-of-the-art technology back in 1989. It did one thing. It made phone calls. What else did you expect? It does one thing. In 1989, Bash was added to the code base. A whopping 9,141 days later, we found out that there was a problem. That's a new record. That vulnerability had been sitting in our code base for all of these years, and all of these systems everywhere were affected. And if you look at from the initial response and the initial report, over the time period, there was more information released, there was patches released, and there was more information as we started to discover it affected other machines. In fact, all these things were something your security team or you had to look at and assess. Am I impacted? Am I vulnerable? Should I apply the patch? Can I apply the patch? Will I break something? Very expensive bug. And this was just one of many, many bugs last year. Talking about Heartbleed, Freak, Poodle. They all have such great names. Sometimes I think I want to go into marketing and go into naming bugs. So if we condense it down, you look, there was actually the initial response, There was a patch 4 days later, 9 days later, 4 days, 1 day, and 2 days. That's a lot of work for your teams. So this is data pulled from Trend Micro's SaaS. So we have a SaaS service of deep security, and we looked at attack data against our customers that were on the SaaS. And within 24 hours, this is what it looked like. These were attackers. Within 48 hours, we started to see it go around the world. And this was real attacks. Like if we looked at the actual packet data, these are serious attacks where they were trying to go after all sorts of private information on these servers. Within 72 hours, it looked like this. There isn't a long window anymore between an exploit being discovered and that exploit being used by malicious people in the population. And you can argue some of these are testers, but some of this is definitely real attacking entities. So let's talk about response. What do you do when there's a vulnerability that's found in your environment? What do you do to respond and stop that bleeding? How do you take it on Amazon Web Services and make sure that you can stop the initial problem until you can do the long-term repair? So first step, we have an architecture here. This may be familiar to you, this may not be. This is from the Amazon set of architectures, great to the URLs at the bottom. And what we have here is a web server traffic. So we're fronting it with Route 53 for DNS. We're using CloudFront for that static content, that CDN services backed by S3, serving up JavaScript and HTML files and images and that sort of thing. And then we're funneling the traffic that's dynamic, the one that has content in it relevant to the users and dynamically updated, to a pool of web servers. Those web servers are EC2 instances, and they're in 2 availability zones. It's set up to auto-scale to handle load of the traffic, and then it goes back through another elastic load balancer to a set of application servers. And those application servers are your business logic. They're processing the requests. And then it finally goes back to a redundant Oracle database on RDS. So great architecture, highly scalable, highly available. There's tons of other reference architectures. We're going to focus on this one as an example because this was a web-based attack. And we're going to go and focus in on the workloads that are your responsibility. For instance, if there was a bug in S3 or Route 53, you don't have to worry about it. It's not your problem. Amazon will take care of that for you. So let's focus in on just your area of responsibility. And there are 2 aspects. There are how are you securing it, and how are you doing the configuration within Amazon. So if we flatten this out, here's the network architecture. We expect traffic coming into the load balancer, distributed to the web servers, then coming back in through a load balancer and distributed to the app servers. The first thing we want to do is verify, is this configuration correct, and have I hardened it properly? So one thing I want to introduce you to is IAM roles. You may be familiar with identity and access management for users. IAM roles can apply to machines, EC2 instances. And that gives those machines the rights to do things. So if we take a look, we want to do an audit here. What happens if that web server was compromised? What happens if somebody gets in there and starts doing things with it? Best practices here is that web server doesn't need access to Amazon, doesn't need to be able to go to S3 buckets, does not need to spin up or shut down instances. So we check the policy, we have nothing attached, that's great. We're following the principle of least privilege in that this web server is not able to use the Amazon APIs. We're limiting that collateral damage that could occur if that first tier got exposed, got compromised. Good first step. Next step we want to do is look at the security groups. Security groups are like the firewall of Amazon. And I've got 4 here. I've got one around that load balancer, one around the web tier, one around the other load balancer, one around the apps. You can see the world is good. We're allowing 0, what we want. If we look at the web server, it's also allowing 0, for port 443. Does that look right? No. It's allowing traffic directly to each of the instances. We don't want that. We want it all going through that load balancer where we're going to move our certificate to. So we can use a trick of the Amazon firewall, a very powerful, powerful trick, to be able to say, traffic to this group over 443 should only come from this other security group. So we could say it should all come from the world security group. And all that traffic's funneled in from EC2, from the load balancer. Very easy to do. And next we're going to go and we're going to look at that middle tier, that load balancer that sits between our web servers and our app servers. So we've saved that. We're controlling the traffic at that tier. If we go to the web to app, what we have here is not too bad. 2 10.subnets. It's good. I mean, it's not allowing traffic from the world, but we could do better. We could use that same trick, and that way, if we add another subnet, if we add a third availability zone, we don't need to worry about adding something to here. We could just say everything from that web tier is allowed to go to that load balancer that's going to go on the way to the app tier. It even allows us to save rules here, because we can delete that other rule and just go down to the one. Very, very powerful feature to be able to segment traffic and control that traffic by security groups. Last one we're going to look at is the app server. In the app server, you can see that we've correctly configured it to only receive traffic from that middle tier load balancer. So next, we're going to look at network segmentation. So we've configured our firewall. What we've done is effectively shut off those shortcuts coming in, and we've established the highways that we thought we had in that network architecture. So I have two public subnets. They're public, as the name suggests, and they're receiving traffic from the internet gateway. And I have two private subnets. And these, I don't want traffic from the internet gateway, so they're being sinkholed to a local interface. So this is our subnet traffic, so we're making sure we segment the workloads appropriately. And the next thing we want to do is go look at our network access control lists, the NACLs. And that's a little bit harder to describe, but it's essentially what is the coarse-grained traffic allowed on each of the subnets? What is allowed even through those EC2? What's allowed inside that subnet? And here, what I'm doing is allowing some traffic. I'm also allowing ephemeral ports. These are the high ports. And Amazon has great guidance for you around how to use ephemeral ports in your applications. So I can configure my inbound and outbound rules for the NACLs. Sound good? So we've cut off the highways. We've configured our traffic the way we want it to go. To review, IAM roles, you want to look at what the EC2 instances have access to. You want to look at your security groups and your configuration there. You want to look at network segmentation in your NACLs. But are we secure from the vulnerability yet? We've cut out those shortcuts, but what about the actual traffic that's going to the web server? That's the next step. So again, we look at this, and what we want to do is apply a way to inspect that traffic that's actually coming into this. So this is where a control like intrusion prevention comes in. Intrusion prevention lets you look at that layer 7 traffic, look at the actual traffic that's traversing on these channels. For instance, I can see HTTPS traffic flowing through. Looks clean, looks good, let it go. I can see another packet, HTTPS going through, looks clean, let it go. Wait a minute, I see SSH traveling over my port 443. Does that look right? Probably not. This is where an IPS can drop it. Getting a little bit more complicated. Now, what if that packet is HTTPS like we're expecting, but it includes Shellshock traffic? Again, we can look for those patterns. We can look for statistical or behavioral event data inside that packet and drop that. A little bit more complex this time. If you're familiar with the web application firewall, again, intrusion prevention can take something like HTTPS with SQL injection. Very common attack that affects all types of languages, all types of applications on the web. Drop that as well. So the analogy is, if we've established these highways, now we're looking at the cars on the highways. We're saying, no tanks on the highways, no bicycles on the highways. We're locking it down to exactly what we want to see. So what we're going to do is we're going to arm that front door. We're going to arm that back door. And we've got that intrusion prevention in place to stop that bleeding. Let's take a look at how that actually works. I'm going to flip back on the black hat. We're going to attack that instance again. But this time, we're going to do it with deep security in place. So this is, we're going to flip over to the console for Trend Micro Deep Security. And what I'm going to do is apply a rule. This is an IPS rule, an intrusion prevention rule. We also call them virtual patches, that is specific to the Shellshock vulnerability. You can see the CVE, and you can see that we're protecting then against that particular vulnerability. We're then going to distribute that rule out to all the workloads that are impacted so that we have that security in place right around each of those workloads, contextually sensitive around the workloads. And then we're going to flip back on our black hat, and we're going to try to attack again. Any guesses as to what we should see when we try to attack again? What should that curl attack result in? Anybody? Good. Nothing. Perfect. What we want to see is it deny that traffic. And in this case, if we run that same command, empty reply from the server. Didn't even bother sending you a, no, that's not good. Just shuts you right down. And the attacker or the attacker's tools then move on to another place. Very powerful control to stop that bleeding. But the vulnerability is still there. So from a review, if we cover all of our instances, if we use workload-specific rules, if we use tools that understand Amazon and machines coming and going. If we cover all our instances appropriately, we can mitigate those within hours rather than days. And as you saw with the attacks, that's a very important aspect because attackers happen very quick. So moving on to day 2, the repair. This is the activity now. You know that you're vulnerable, but you're patching it through network means. You're using a compensating control to protect against that vulnerability. But we actually want to patch the real systems. We don't want to leave that in that state forever. So again, our architecture, here we are, we're protecting the instances. If you're using best practices, you're actually spinning up each of these instances from what's known as an AMI, or some of the Amazon people say AMI. Choose whichever you like, AMI or AMI, but it's your template that forms all of your instances. So next step we're going to do is we want to patch that template. And how do we do it? We take it, we spin up an instance that's a copy of that. It's a running copy of that template. We're then going to configure it. That's apply the patch, apply the latest software, and then we're going to bake it. Not rocket science here at all. But do we put it in production right now? No. We don't know what happened here. We want to test. So we instantiate that again. Another running instance. This is free, right? It's Amazon. You can very cheaply spin up additional machines, no problem. We want to test it. Ideally, we want to do the testing with automation, though I understand for some applications and some of your workloads that might not be possible, and that's where manual testing comes in. But ideally, we automate all this because this is going to happen again and again and again and again. And in fact, if you do this, and if you use things like pipeline and code deploy, you'll find your operational practices around code deployment also improve. Not just your security, but your operational practices actually around deploying code. So if we take a look at this then we destroy that instance. Let's take a look at this in action. Here we have our running instances. They're serving up traffic. We virtually patch them, so we don't want to take them down. We want to keep servicing traffic. We don't want to go offline just because there was a vulnerability. And next, we want to take that AMI that we had, the original one, and we want to create an isolated test area. This could be a VPC. It could be an availability zone. It could be a region. It really doesn't matter. Just somewhere where you can go test this workload. And then we take the original template and we spin up a copy of it. So we've got a copy running. We can start to then throw things at it. The first thing we want to do is, of course, patch the vulnerability. But you might also want to use that as an opportunity to deploy the latest code base. You might want to use it to configure other things or run system updates. But you've created a patched one. And then we have AMI, and we'll call it AMI v2, our second instance of the template. Do we put it in production? No. We wait and we test. And again, automation is key here because that can speed up this process dramatically. So we're going to take that AMI, we expand that isolated test area, and we spin up another instance. And this is where we want to run the batteries of tests against it. The more, the better, because we want to make sure that the patch didn't break our application. And of course, everything passes, all your instances are good to go, you're ready to run, and we're approved that instance, and now we're going to put it into production. But of course, we don't want to just shut everything down and put these new ones into production. So we're going to take that template, and we're going to spin up a new set of instances. This is where blue-green deploys come in, if you've heard that terminology before. This is also where the magic of Amazon comes in. Two things. Load balancer lets you redirect traffic, and because it's Amazon, you don't have to worry about planning for the capacity of both of these running in parallel. So you can have parallel workloads for that short period and only pay for that. So we take that, we run them in parallel for a little while, we switch the traffic over to the green group. There's still connections going out of the blue group. We don't want to shut that off. It will cause errors for our users. But once that's all wound down, we can then retire that blue group. And what we've done is a zero downtime deployment where we've patched the security hole, and we've been able to do that without any impact to our users. So we've armed the front door, we've armed the back door, and now we want to look at these instances. If we're following best practices, we're actually not logging in, ever. In fact, you shouldn't log in ever. If you're using stateless machines like this and you're patching it on the AMI and spinning up templates, you should lock down SSH and RDP. Don't use it. And this is where a control like integrity monitoring can come in, is that you can use that to detect drift. And things are going to change. Applications do things with temp files and so on. But there should be only predictable change and uniform change across your instances. And you should be looking for anomalies that mean that people have got in past your lines of defense. So integrity monitoring is a way to detect not only file system change, but change to the registry, ports, processes, users, groups, that sort of thing. And Trend Micro does that in the same way in terms of an agent on the guest and the instance. And you can send alerts. So let's say there's a variant of Shellshock nobody's discovered yet. Again, we're going to use deep security as our tool here. And we're going to monitor our SSH key material. That's an important part of our configuration of our machine. So I'm putting back on the black hat. I'm going to attack it again. I'm going to use that same variant of Shellshock, and I'm going to list your SSH key back to me. I'm then going to take my SSH key, and I'm going to inject it in there, and I'm going to remove your SSH key. I've effectively hijacked your instance. I've stolen your workload. Wouldn't you like to know if that happened to you? So this is where integrity can be very powerful, that here we can see SSH key material has been modified. You may want to go look at that. So to review, we want to look at our configuration. That's all of the service configuration for Amazon, and there's a great document out there, security checklists. Take a look for AWS security checklist. We want to apply intrusion prevention to stop that initial bleeding. We then want to patch using blue-green deploys, or if you have to, in-place patches to actually remediate that vulnerability, but testing is the key. Automation is a very important aspect of it. And then we want to leverage integrity monitoring to look for drift in those particular instances. So if we summarize, moving to Amazon Web Services really gives you unprecedented visibility into your environment. You have things like CloudTrail, that now you know everything's an API key. So you know if Joe walked into the server and unplugged this LAN cable and plugged that, it doesn't exist. In the virtual world, everything's an API call, everything's recorded. And if you combine that with security tools, you can also pull out, I know this instance was on at this time. It was protected by this. Here's what happened to it. Yes, it went away, and yes, we auto-scaled and burst, but you have that visibility, that unprecedented visibility provided by the Amazon cloud. You also have better security. We talked about unlocking that world-class security, that economy of scale that really lets you have the best facility security, the best power and cooling and lighting and network connectivity worldwide. Better security in terms of tools. You're moving away from that hard outer shell into arming each of your instances, allowing you to put security around each of your workloads. And most importantly, automation and save time. So if you use techniques like the blue-green deploy, if you automate that workflow, you can save a tremendous amount of time. Deployments, you save a tremendous amount of time. Using the right security tools can save you a tremendous amount of time. And everybody in operations and security needs some of their time back. So with that, I'd like to thank you, and please come see our booth if you have a chance later on today. Enjoy the rest of the show.